Hello everyone, we are working on the Inscribed Angles tab in the flipbook. So open your flipbook up to Inscribed Angles and let's see what we need to know. Inscribed angles are another type of angle that we haven't seen very much yet as far as measurements. We had it in our vocab, and we know that an inscribed angle has its vertex on the circle, and its two sides are each chords of the circle. That's what makes it an inscribed angle. Today we're going to look at the measures of inscribed angles and how they relate to the arcs in the circle. And what we have right here over here is the relationship that I'm talking about. It says the measure of an inscribed angle is equal to half, I am circling that one, half the measure of the intercepted arc. So angle equals half of the arc. So over here on my picture, I'm going to color code this and I'm going to show that relationship. I'm going to highlight the arc, and I'm going to highlight the angle, but that doesn't mean they're the same, because the angle, which I'm calling x, is half of the arc, which I'm calling 2x. So I kind of turned it around to avoid the fraction. Instead of angle equals half of the arc and putting a half on this, I turned it around and said that that means the arc is twice as big as the angle. So that's the relationship we're going to be working with today. In addition to that, we still need to remember that central angles, just come over here. You've got this tab, I'm just writing it here so I have it. Central angle that looks more like this with its vertex at the center, a central angle always equals its intercepted arc. So we have to know the difference between those two and when to say the angle equals the arc because it's central, and when to say the angle is half of the arc because it's inscribed. The biggest thing is that people get those two mixed up. And then we have three special cases here. The first special case has an inscribed angle, and this inscribed angle is intercepting half of a circle. They called it intercepting a diameter because they have this diameter drawn in. I like to say it's intercepting a semicircle. Because there's that, and there's the angle that goes with it. Now, before I put my big old blob of a purple line there, you saw that they had already marked that as a right angle. Because the arc is 180, and we know our inscribed angle is half of that, we know that this is always going to be 90 in this situation. They probably won't mark it for you. They expect you to know. So anytime you have an inscribed angle and it intercepts a semicircle, half of a circle, since the arc is 180, the angle is 90. Okay? Point B, by the way, could be anywhere along here. You can kind of slide it back and forth, and it still works. The next one, going to color code on this one. Let me start with, I'll use blue. It says if two inscribed angles intercept the same arc, then the angles are congruent. I need to change my line style here, make it a little bit smaller. There we go. So angle B, if I trace out angle B, it intercepts that arc. So I know that angle B is half of that arc because angle B is an inscribed angle. If I go with angle C instead and I trace that, angle C intercepts the very same arc. So angle C is also half of that arc. Well, since angle B is half of that arc, and angle C is also half of that arc, that makes angle B and angle C exactly the same. It's kind of something that's tricky to see, but it's an easy relationship once you do see it. I really suggest tracing them, maybe even color coding them to see that that's going on. Also, I always say whenever you see this bow tie kind of shape, that's something to be watching for, because that's the shape that kind of indicates that we might have more than one inscribed angle giving us the same arc. All right, and finally on our new information, inscribed quadrilaterals. We have an inscribed quadrilateral because all 4 of its corners are on the circle. If 3 of the corners were on the circle, not enough. 2, definitely not enough. 1, don't even think about it. Has to be all 4 corners on the circle to be inscribed. That's a special case, and when we have that special case, something special happens. Angle A and angle C are opposite vertices. If you look at angle A, if I trace it out, goes with that arc. And if you look at angle C goes with that arc. Now, despite my shaky hand there drawing that, if I look at the red arc and the purple arc, I've covered the whole circle. And so I've covered all 360 degrees. Since angle A and angle C are inscribed angles, they are half of their intercepted arcs. So if the arcs total 360, whole circle, the angles are going to be half of that, and the angles are going to total 180. And so A and C right here total 180 degrees. Again, this is true when the quadrilateral is inscribed. All of the vertices, all of the corners are on the circle. The exact same thing would be happening with angle B and angle D. Angle B and angle D are opposite angles in this inscribed quadrilateral, and so angle B and angle D would also total 180 degrees. So inscribed angles, half of their intercepted arc, as we call it. If the arc happens to be 180, then the angle will be 90. If 2 inscribed angles, or 3 or 5, or however many, give us the same arc, then those angles are the same. And finally, in our very special case of inscribed quadrilateral, opposite angles always total 180. All right, let's go ahead and scroll down and look at some examples that use our inscribed angles. Number 12 is a problem where we just need to find a bunch of angles and arcs and then fill it in over here. So let me make sure I've got, there we go, something that's not going to take up too much space there. Let's look at the picture first, and then we'll worry about this over here. First thing I notice is that we do have a diameter, because I see that center point mark there. And so this is a diameter. So I happen to notice that this would be a semicircle. If this is 106 in my semicircle, then 180 minus that tells me that this arc would be 74. And then if I kind of trace that one back, I find an angle here that goes with, that intercepts this 74 degree arc. That doesn't make this angle 74, This is an inscribed angle. And so this angle is half of that intercepted arc. And so that angle would be 74 divided by 2. And that is 37. Again, I'll worry about what they ask about here in just a minute. I'm just writing stuff in. 37 for that one. All right, let's see what else we've got. We've got this angle over here. If I change colors, make sure it's still on thin. This intercepts the 106. It's inscribed, so it's half of that. And so that one's going to be 53. And let's see, if that's 65, if I trace that one out, I know my colors are overlapping each other. Whoop, I got a thick line that time. If that's 65, then that arc would have to be twice 65, so that would have to be 130. Once again, because of the semicircle, if that's 130, 180 minus that tells me this is 50. And that tells me that this angle, if I trace it back, right there, is half of that, which is 25. Let's see what I've got over here and see if I need to keep looking for other things. Angle STR. Angle STR, we had that at 53 degrees. Angle QRS. QRS. Okay, I didn't write that one in, but angle QRS. If I grab black marker, how's that? QRS gives me this whole semicircle. So it's half of that, which is going to make for 90 degrees. TQ, we have that, 50 degrees. SQR, SQR, oh, didn't do that one. That one would be half of this arc. So that one's going to be 53 degrees. That's the way I do these. I just kind of work back and forth. I find things over here, and then I see what they're asking about. ST, the arc, is 130. We have that on our diagram. That's a 0, not a 6. And QR, 74 degrees. Covered everything they want. All right, next up, problem number 13. Let's take a look at problem 13 and see what we need to do. On problem 13, it's a lot less complicated looking than number 12 was. We have an angle and we have an arc, and we know that the angle is 1/2 of the arc. 1/2 times the arc. So let's go ahead and put in what we know. The angle is 71 equals 1/2 times the arc. I'm keeping the parentheses, 16x minus 2. Now there's two ways I can solve this. I can multiply the 1/2 in, distribute it in, and go with that. Or what I like to do is just get rid of this 1/2 by doing a times 2 on this side, because then that will cancel that out. Of course, if I have to multiply by 2 on this side, same thing goes over here. So when I multiply this out, I get 142 equals my 16x minus 2. I don't need the parentheses anymore because nothing's being multiplied by that. So now I can add 2 to both sides and then divide by 16 and find out that x equals 9. They asked for the value of x, so I'm done. If this is a quiz or test, you bet I'm plugging that in and making sure that that arc is really twice as big as that angle. Number 14, same relationship, so same deal. The angle, the 2x minus 5, I know that's a little hard to read right there. Angle, 2x minus 5, equals 1/2 of the arc, 5x minus 27. Getting sloppy there, sorry. Times 2 on both sides, times 2 over here to cancel the fraction. And then a times 2 over here. Notice I'm putting in parentheses. I have to multiply 2 times everything over here. So now I have 4x minus 10. And over on the right side, don't need the parentheses anymore. Nothing's being multiplied times. 5x minus 27. And we solve that out and we get x equals 17. It's supposed to be an equals. There we go. And on this one, they asked me to plug it back in. So first of all, that equal sign is really annoying me. Let me try a little harder. Get my purple skinny pen. There we go. Equals. Don't drag my hand this time. There we go. Now that I know x equals 17, plug it in for EC. That's the 5x minus 27. And I find out that the measure of EC, arc EC, equals 58 degrees. Last one, number 15, uses our special information about an inscribed quadrilateral. Look at that. 1, 2, 3, all 4 vertices on the circle. It's inscribed. That means opposite angles total 180. So this is an easy one to set up and solve. 11x minus 29 plus, no, not equals, plus the 6x plus 5 equals 180. There's my equals. And so when I solve this out, I end up getting 17x minus 24 equals my 180. Add the 24 to both sides, 17x equals 204. Divide by 17, and I find out that x equals 12. A quick check, though, says we're not done. Need to put that in for angle W, which is the 11x minus 29. And when you do, you find out that the measure of angle W, put in the 12 right there, it's 103 degrees. So that's it for our flip book and our inscribed angles. Keep in mind, inscribed angles, vertex on the circle, always half of the intercepted arc. Don't forget, though, that we also know that central angles, vertex at the center, always equal the arc.